In this video, I will be explaining the physics behind rocket flight, specifically how Newton's three laws, as well as conservation of momentum, applies. Newton's first law states, an object at rest stays at rest, and an object in motion stays in motion, unless acted upon by an unbalanced force. In the case of a rocket will unsurprisingly stay on the launch pad unless acted upon by the force of its engine. Likewise, when a rocket is in flight, it will stay in motion unless acted upon by an outside force, otherwise known as gravity. Knowing this, aerospace engineers typically design their rocket engines with enough force to overcome the force of gravity on their rockets, which can be calculated by the equation F equals mg, where F is force, m is mass of the rocket, and g is the force of gravity. Newton's second law states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Simply put, the greater the net force generated, the greater the acceleration of the object that the force is being applied to. However, if the same force is being applied, but the mass is increased, the acceleration will be less than compared to the rocket with less mass. Rocket number 1 has a simple rocket engine with a single module of fuel. Carefully watch the rate at which the velocity increases here. Rocket number 2 has an identical rocket engine, except this time it has two modules of fuel. Observe the rate at which the velocity increases here. For the sake of clarity, Rocket 3 has the same engine, except this time it has 5 modules of fuel. Newton's third law states that every action has an equal and opposite reaction. In a rocket engine, hot exhaust gas is produced through the combustion of a fuel with an oxidizer. The hot exhaust gas flows through the rocket nozzle and is accelerated to the rear of the rocket. This is the action. In reaction, a thrusting force is produced on the engine mount. The thrust then accelerates the rocket upwards. A rocket conserves momentum through the equation P equals mv. We can turn this into P equals mass of actual rocket plus fuel times velocity of the rocket. Fuel is the only variable within the mass coefficient. There is an inverse relationship between the amount of fuel in the rocket and the velocity of the rocket. As the velocity of the rocket increases, the mass must also decrease.